Okay, so in this video we're going to look at counting permutations, rearrangements of items, in other words, where some of the items show up more than once, so they're duplicates. So let's start with a basic example first. That's just a basic permutation. So let's ask, in how many ways can the letters FISH be rearranged? Okay? And how many ways can FISH be rearranged? And so when you look at the word fish, there's 4 distinct characters, okay? And so if you're looking at rearrangements of that, well, you've got to pick a first letter, you've got to pick a second letter, a third letter, and a fourth letter. You're using all the letters if you're just rearranging these. And when you choose a first letter, you've got 4 options. It could be the F, the I, the S, or the H. But your second letter, if you're rearranging these, you're using all 4 letters, but you're not reusing any one of the letters necessarily. So the next letter, there are 3 options, because you can't use the letter you chose first. And for the third letter, there's 2 options, and for the fourth letter, there's 1 option. Now, the order of these matters here, so it's just a straight permutation. You don't divide by anything. You just 4 times 3 times 2 times 1 is 24. So there's 24 ways you could rearrange these letters to get a new word, let's say. Okay, so that's simple enough. But what happens if we ask the question like, in how many ways can the letters of cheese be rearranged? That's a little bit harder question, because when you look at the word cheese, there's 3 E's, okay? So let's do this. Let's think of the E's as being, let's label each of them as something different, although they're the same letter. So let's call the first one E1, the second one E2, and the third one E3. Right, so this E has a distinct name from this E and this E, okay? So that can be handy when we're tracking different ways to rearrange these letters, because what's going to happen is CHEESE is one arrangement, just one arrangement. The problem is if we were to count the permutations, so let's do that. You would, same setup, you're going to have 1, 2, 3, 4, 5, 6 letters. So you're going to have a first letter, a second, a third, a fourth, a fifth, and a sixth, okay? No problem there. But if you just say, all right, well, my first letter, I've got 6 options. I could choose any of these letters. My second, I've got 5, and then 4, 3, 2, 1, making sure to use all the letters to get a rearrangement. The problem with that is the fact that cheese, this particular arrangement, in fact, every arrangement of these 6 letters is going to have 3 E's. So let's look at all the different ways you could get the arrangement cheese by putting the E's in different places, okay? So here's one way to arrange the word cheese. But we could also leave E1 where it is and switch E3 and E2. That still spells cheese. That's the same arrangement of letters. Just the E's are in a different spot, you see? And if we use this reasoning, we're going to count those as 2 different arrangements. So the question is, how do we fix this? Well, the first thing is we've got to figure out how many copies are there of each arrangement, and we need to divide by that number, okay? So we're definitely going to have 6 times 5 times 4 times 3 times 2 times 1 as a permutation. But then we have to eliminate all the copies of the various arrangements, so we're going to have to divide this by something, okay? So let's figure out that something. And we can do that by analyzing this single arrangement of the 6 letters. So now we have 2 arrangements of that same cheese word, but there's other ways too. We could put the E2 in front and then have E1 and then E3. That still spells cheese. We could do E2, E3, and then E1. We could do E3, E1, and then E2. And last we could do E3, E2, and then E1. So what happens here is when you look at the three E's, right? We've arranged the three E's in different places for all of these, but all of these still result in one arrangement, just the word cheese. They all spell cheese. We just move the E's around. So how many copies do we have? Well, you can see that we have 1, 2, 3, 4, 5, 6 copies. 6 copies of this arrangement. Now, why is that? Well, the reason is we have 3 E's that are being rearranged. And the question is, how many ways can you arrange 3 items? Well, if you want to arrange 3 items, you've got 3 options for your first item, 2 options for your second, and 1 option for your third. So there's 3 factorial ways to arrange the E's, resulting in 6 copies. 3 factorial is 6. So what we have to do now is come over here and divide this answer by 3 factorial to get rid of all the copies of the various arrangements. Okay? And you could do this on a calculator or something, but this one's easy enough to do without a calculator. This is 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And then you can simply cancel the 3's, the 2's, and the 1's. So you get 6 times 5, which is 30, times 4 is 120. There's 120 ways to rearrange the letters of the word cheese. Okay? So no big deal. But let's look at a harder example. What if more than one of your characters repeats, has duplicates? So let's look at in how many ways can the letters of football be rearranged. And this time I'm not going to draw out all of the possibilities. I'm just going to show you the logic extrapolating from what we did before. So for football, we have 1, 2, 3, 4, 5, 6, 7, 8 letters. So we're going to have a first letter, second, third, fourth, fifth, sixth, seventh, eighth. We're going to count these arrangements as if every character here is unique first. And then we're going to divide by the number of copies of each that there are. So your first letter, you've got 8 options, right? You got 7, 6, 5, 4, 3, 2, 1. So we multiply all of that out. Well, that's 8 factorial. Now what we have to do is divide by the number of copies of each, okay? Divide by the number of copies of each arrangement. We know there's going to be copies because we have 2 O's, we have 2 L's. Those could move, switch places and still have the same arrangement, so we're going to result in copies. So now because there's 2 O's, the O's can be rearranged in 2 factorial ways. And because there's 2 L's, the L's can also be rearranged in 2 factorial ways. So what we have to do here is divide 8 factorial by 2 factorial and another 2 factorial to account for the arrangements of the O's and the L's. Okay? So this is going to delete all the copies of various arrangements. Now let's see here. Let me grab my calculator and so we can get the number here. I could do this by hand probably, but let me just use the tools that I have at my disposal. 8 factorial over 2 factorial times 2 factorial equals 10,080 ways that those letters could be rearranged. And we've taken into account all the various copies of the arrangements. Okay? So anyway, it's a permutation, but within that permutation you have some items that are exactly the same. So if you switch them, it's still the same arrangement, but you have to eliminate the count of those copies by dividing. Okay, so I hope the video helps. Good luck.